Let's look at this 3x3 system, 3 equations, 3 unknowns. We have 3 options, Cramer's rule, inverse matrix method, or a Gauss-Jordan elimination. Let's use the Gauss-Jordan method. We start by creating the augmented matrix, which is the matrix of coefficients with x, with y in the second column, and coefficients with z in the third column, then the vertical line instead of equal signs, and the right hand side of the system. Okay, and let's use the classical Gauss-Jordan elimination, which means we're going to move along the diagonal. Our first pivot is on the diagonal, first entry. We have to eliminate, using elementary operations, every entry below it, which means this 1 in the second row and the -1 in the third row. To get rid of the 1, you simply subtract from R2, subtract R1, and to get rid of the -1, simply add to the third row, add the first row, and you're gonna get your 0. The first row remains unchanged, so just copy it. In the second row, we subtract R2 minus R1, so it's 0, 1 minus 1 minus 2 is -3, 9 minus 4 is 5. And in the third row, we're adding, so here you have -1 plus 1, 0, 1 minus 5 is 3, and 1 plus 4 is 5. Okay, moving on to the second step, our next pivot is on the diagonal, second element on the diagonal, this one, and we have to eliminate everything below it, which is just this one entry in the third row, by simply subtracting the second row. So the first 2 rows remain unchanged. We can copy them. And from the third one we subtract, so it's 0, 0, 0, 0. And now we have a situation of 2 pivot columns, first and second, and 2 non-zero rows, which means our elimination is over. The only thing remaining is read the solution from that system, right? Once you have the number of pivot columns equals the number of non-zero rows, means your elimination step is done. Now, the pivot columns, which are columns corresponding to variables x and y, give us the basic variables, tell us that x and y are basic variables. And the column which is a non-pivot column, in this case column corresponding to variable z, tells us that z is the free variable, or simply, or sometimes called a parameter. Now, just as we created from the system of equations, we created augmented matrix. From this augmented matrix we can write down a system of equations. In the first one we have 1x, 0y, 2z equals 4. Second row, 0x, 1y, -3z equals 5. Okay, these are 2 equations. Now, since x and y are basic variables, we can write these equations, we can solve the system for x and y. From the first equation, x equals this much, and from the second equation, y equals this much. Now, z is a free variable, a parameter, so z can take on any real value. And that is the system, the solution of the system. The system has infinitely many solutions with one parameter.